Madam, you are unmute.
Yes. Am I audible now?
Yes, yes, madam.
Yes.
Principal of the Institute, Dr. Vidula Soni, Madam. Coordinator of the FDP, Deepak Ray and Chetan More, sir. Faculty members and participants from various states of the India. Good afternoon to all, and on behalf of Department of ENTC, I welcome you all for the Faculty Development Program on a deep dive into artificial intelligence and its application workflow using MATLAB. Just to introduce with the Department of ENTC, the department started in the year 2007 and at present we have intake of 120. The department is well equipped with the various laboratories and the faculty members of the department are highly qualified with the strong research interest. The placement of department is always more than 85%. We have planned this faculty development program to introduce you in the field of AI and its application through the MATLAB. So two sessions are the introductory session, that is introduction to deep neural network by Dr. Pallavi Deshpande, that is scheduled today. And tomorrow we have a session by Dr. Rajesh Kongde, who is working as professor in the department. The session is based on the evolutionary optimization algorithm, and followed by these, we have 3 days MATLAB hands-on for the AI applications. So let us all take the advantage of the opportunity to learn together. Thank you.
Thanks a lot, ma'am. Now I would like to briefly introduce our respected principal, Dr. Vidula Soni, ma'am. Dr. Vidula Soni, madam, is a renowned educator and leader with an impressive record of achievement. She holds a BE in Civil Engineering from College of Engineering, Pune, graduating with first class with distinction and a gold medal, followed by an ME in Civil Structure from the same institute, and a PhD from Bharati Vidyapith University, Pune. Her accolades include the prestigious Cosmos Adi Shakti Puruskar and the Outstanding Leader in Higher Education Award in 2024, along with multiple awards from the University of Pune for her academic excellence. With 37 years of teaching experience, 25 years in research, and 4 years in industry, Dr. Soni Madam has made significant contribution to academia and civil engineering. She has published 24 international journal papers with 7 indexed in Scopus in the last 3 years and have presented papers at numerous conferences. She holds a patent granted by the Government of Australia and has another filed in India. Her leadership has been instrumental in the accreditation of our department by NBA, and her leadership skills are also visible in consultancy projects like the Jal Yukt Sibhar Abhiyan by the Government of Maharashtra. Dr. Soni Madam commitment to education and research is evident in her role as firstly as a NBA coordinator, as a guide for PhD and MTech students, and also in her collaboration with IIT Mumbai on projects like the Unnat Maharashtra Abhiyan. Her extensive experience and numerous achievements make her an exemplary leader and an asset to the college. Now I request our Principal Madam to address the attendees of the workshop.
Thank you, sir. Thank you for your kind words. Good afternoon, all of you. I welcome all the participants, resource persons, the faculty member of ENTC department for this faculty development program on a deep dive into artificial intelligence and its application workflows using MATLAB. I congratulate the department for arranging this FDP on a topic which is the latest requirement of the technology of the current industry, and accordingly the department has arranged this particular faculty development program with a scope of MATLAB and with the hands-on training on MATLAB. I'm also glad to know that 2 faculty members from the departments are working as resource person for this particular faculty development program. That itself indicates the quality of the faculty members in the department and in the institute. This institute, that is Bharati Vidyapit deemed to be University College of Engineering Pune, was established in the year 1983 and is one of the oldest institute in Maharashtra. It is affiliated to Bharati Vidyapit deemed to be university from year 2000. The university is deemed to be university which is accredited by NAC 3 times and with A plus grade, and now we are going for the fourth cycle of accreditation. This university is also ranked by NIRF every year with the ranking less than 100. The college runs 11 undergraduate programs, 8 postgraduate programs, and 8 PhD programs. We are having a lush green campus with good state-of-art infrastructure, separate library building, and because of this, the departments of this college also got accredited because of the quality teaching and learning and NBA for 3 years. And recently we got accredited in September 23. The college is having very good placement as well as very good research by the faculty members, and more than 750 research papers are published in the last 3 years, out of which more than 250 papers are in the Scopus Index journals. The patents filed in the last 3 years are about 24 in number, out of which 14 patents are granted. The placement is always above 85%, and the college has received various rankings, that is 3 times ranked NIRF less than. We have a separate institute innovation council which has the ranking of 3.5 out of 5. The college has received various accolades and various rankings from various magazines which rank the college to be one of the best engineering institute as well as third in the West Zone and 31st in the top 175 engineering colleges by Times of India survey. The college works has been identified as a spoke center under Skills Prime program by CDAC Pune, and we have received the award from Institution of Engineers India also as Excellence in Engineering Education. The college has received the funds under Vishwesvaraya PhD scheme as well as under the Ramanujan Fellowship, as well as it has developed a SC/ST Development Center and MSME Development Center for this college. Placement of this college is always above 85%, and the college has received the Best Engineering College for Placement award. The faculty of the college is achieving various prizes and various achievements every year, as well as the students have received various achievements. It is a regular practice of this institute to arrange for the various faculty development programs so that the faculty gets exposure to the latest knowledge and technologies, not only attending these programs but arranging the faculty development programs. So this is one of the program which is arranged by ENTC department. So I once again congratulate the faculty members and the head of the department of the ENTC program. I'm glad to know that the more than 400 participants have registered for this program, out of which, out of these 400 participants, about 250 are from Maharashtra, but all the others are out of Maharashtra also. So this will be useful for the participants, and I hope that this faculty development program will add to the knowledge and hands-on training on MATLAB for all the faculty members. Once again, I thank all the participants for joining this faculty development program. I congratulate the department and my best wishes for completing and conducting this particular faculty development program. Thank you.
Thanks, madam, for your kind and motivating words. Now I would like to propose a vote of thanks to our principal, Dr. Soni madam, and our HOD Oja madam for giving us an opportunity to conduct this event. I want to thank Mr. Amit Kumar to help us in conducting this event. I also want to thank my co-coordinator, Mr. Chetan More, and my colleagues for coordinating and helping me in this event. And last but not the least, I want to thank our participants for making this event a successful. Thank you all. Now we'll starting our first session in few minutes. This link is valid for that session also.
Madam, please request all the participants to start the camera and take one photograph of all the participants for your record.
Yes, madam. So all the participants are requested to keep your camera on so that we can take the snapshot. Deepak
We will
sir,
be
you
starting
can.
in few minutes.
Deepak sir, you can take the snapshot.
Okay, ma'am.
Let more number of participants
Yes,
start.
let us wait for all
Wait for
to
few.
make the camera on. All participants are requested to make the camera on.
Okay, madam.
Deepak sir, have you taken the snapshot?
Yes, yes, I'm taking the pics, madam. I'm just checking. I'm on the sex. I'm on the third page, I guess. Yes.
Okay.
Is it over?
Yeah, madam. You can leave, madam. Your pic has been
Okay.
taken. You can leave, madam.
Thank you so much.
Okay.
Yes.
Yes.
Thank you, madam.
Yes.
Okay, I'm done. Those who have put their camera online, I have taken the pics, madam. Now we can start the session. Okay. Now I would like to introduce our first speaker for this inaugural session. Our first speaker for today's session is Dr. Pallavi Deshpande, madam. She is working as associate professor in the Department of ENTC in this college only. She has total experience of 23 years with a PhD in electronics engineering, specializing in speech signal processing, alongside core competencies in digital signal processing, biomedical signal processing, microwave antenna, and embedded system. Her doctoral research enhances her skills in analyzing and manipulating speech signals. She has experience in medical imaging as well. She has a collaborative project going on with University of Augsburg, Germany. In total, she has 35 plus publications in reputed journals and completed 2 research projects funded by BCUD SPPU. She worked as reviewer for many conferences and few journals as well. She has written 2 book chapters and 1 book on artificial intelligence on her credit. Now request Pallavi madam to start the session.
अरे आयुष भाई बड़ा आदमी बन गया सर कहाँ बड़ा आदमी से बात करें
Now I request the participants to move their mics also.
ये कौन दो के
I request participants to mute their mics.
खाली सीजीपी लेके कुछ फायदा नहीं है कुछ करके दिखाया तो उसका फायदा है
Pallavi madam, you can start screen sharing.
Madam, you are on mute. Pallavi, madam, you are on mute.
Hello, am I audible?
Yes, ma'am, you are
Yes.
audible.
Okay. Deepak sir, there
Yes,
is one request.
yes, yes.
Actually, some drilling work is going on. Can you ask please someone to tell them?
Okay,
Just
okay. Sure, sure,
in
sure,
front
sure.
of, I think that
Just
ladies washroom, no? Somebody is drilling, so
give me 2 minutes, madam. I will stop that, please.
yes, ma'am.
Okay.
Sir, please, sir. Thank you, sir. Uh, okay. Is my screen visible?
Yes, ma'am.
Okay. Thank you. We'll just wait for a second so that that drilling work will get some. Okay, a very good afternoon, everyone. Am I audible? Should I start?
Yes, ma'am.
Okay. Good afternoon, everyone. Honorable Principal Dr. Vidula Soni ma'am, respected Dr. Shruti Oza ma'am, distinguished faculty members, esteemed colleagues, and dear participants. It gives me immense pleasure to welcome you all for this Faculty Development Program Session 1. I am honored to be here as a speaker today. First and foremost, I would like to extend my heartfelt gratitude to Bharati Vidyapit, College of Engineering, Department of ENTC for organizing this event and giving me the opportunity to share my knowledge and experiences with such a talented and diverse group of audience. Today's session, we will focus on fundamental concepts on deep learning in AI. Since we are beginning today and it's the first session, so we would like to go with some fundamental concepts so that it will make the further journey for 3 to 4 days ahead little comfortable and easy for everyone. So deep learning basically to start up with, very good afternoon, ladies and gentlemen. Thank you for being here today. In recent years, deep learning has become a leading method in machine learning. It's widely used because it can handle enormous amount of data and achieve amazing result. Basically, this is very much a driving force behind going into the deep learning mode of AI or ML domain, we can say. Even like often even better than human performances in many of the tasks. Even if it's artificial intelligence, it has really gone at par in many of the tasks. Deep learning has also grown quickly, and it is now used in many areas, including cybersecurity, natural language processing, bioinformatics, robotics, and medical information processing. So let's begin this. I'm sorry. Artificial intelligence, machine learning, and deep learning, these are the very connected terms. In this, uh, actually, I am on the slide number 2. Is it visible to everyone?
No,
Madam,
ma'am,
no.
it is showing only
No.
first slide.
Oh, yes.
First slide.
I don't know why it is showing like that.
I think your net problem.
Because I am on now slide 2. So Maybe I'll come off this mode. Now is the second slide is visible? I just came out of the
Madam, you
presentation
can,
mode.
yes, you can, madam, shut down your camera also, madam. Sometimes what happens, because
Okay.
of this bandwidth problems,
Yeah.
sometimes the slide gets stuck.
Okay. Okay. I'll just try this last time, this slide. If it doesn't get changed, I'll immediately switch off the camera. Now the
Sure.
second slide is visible.
Yes, yes.
I put it on the presentation mode also. Okay. So this is a deep learning family, and one can say it's a layered architecture where artificial intelligence, machine learning, and deep learning's positional functionality is being shown. So we can say that artificial intelligence is a bigger umbrella or a broader umbrella where the efforts are made or the attempts are made uh, for making the machines to learn and reason like humans or to act like human. So whenever we see the artificial intelligence uh, course contents, or when we take any artificial intelligence course, mostly the initial few chapters are on many a times sensors, then processing units and actuators. This is what is a human system also. We have lot many sensors to sense our physical world around us. Then we have a processing, that is a brain, and then we have an actuator. Like actuator is something like you can say hand is an actuator. So if we see that something is falling, then immediately we can take action and we can catch hold of something. So sensor senses something, and that something is sensed, that processed in the brain, and according to that the appropriate actions have been taken. This is a very basic human behavior. So initially when artificial intelligence work has started, it has aimed towards making the machines to behave like a human being. Later on machine learning things come in the picture, which is again what we can say, as it's an inner circle, I can say it's a subset of artificial intelligence. And definition wise, I can say a subset of AI which is focused on the development of the algorithms that allow machine to learn from and make the predictions and decisions based on the data. So basically machine learning aim towards running or developing or having the algorithms in the machine, running inside the machine using data, so that those data can make the algorithms more powerful in the terms of even they can do some predictions or they can make some decisions, obviously based on statistical models or some formulas or some equations which are implemented for the uh, algorithm, or which are implemented for the particular task inside the algorithm. Now coming down to the topic for which we are all have to gathered together, that is deep learning. Deep learning again is a subset of then machine learning. So it is rather, we can say, a specialized subset of machine learning that uses neural networks with many layers to analyze various factors of the data or various aspects of the data, so that then it can do the same thing. Actually it can make the predictions, it can make the decisions, it can even make the decisions which are like very complicated for a human being to analyze the data and to make correct decisions. For these purposes deep learning is very much um, proposed, or it was very much invented by the researchers. So in summary, we can say AI is a overarching concept of creating intelligent machines, where ML is the method within AI which focuses on the algorithmic approach and the data to learn and to make the decisions. And finally, coming down to deep learning, we can say that it is more advanced and a data intensive form of ML. Machine learning has got so many algorithms, deep learning also has got so many algorithms, but then those two algorithms, even if they are working for same goal, what is the difference between them? Deep learning can handle a large amount of data, or rather I will say, if there is a large amount of data, then only the efficiency of the deep learning algorithms can be guaranteed. Otherwise machine learning algorithms do much better if you have small amount of data. This is what is, we can say, that it's a beauty of deep learning. uh, Now I'm on slide 3. Is it visible to everyone? Slide 3.
No, no, ma'am. Yeah, now it's showing third.
Okay, so in presentation mode, it's not going ahead. Okay, So now going to one layer in a little detail, so that only deep learning also can be very well understood, because it is again a subset. So the innermost circle inherit all the properties of outermost circles also. So again, to little go in depth with, I can say that AI is a branch of computer science that deals with the machine's ability to imitate the intelligent human behavior. A more recent focus in the field is on enabling machines to identify the characteristics of unfamiliar phenomena by taking advantage of pre-existing knowledge. So once we have a pre-existing knowledge of something, and then we train our networks, and unfamiliar phenomena also it will be able to recognize, it will be able to predict. So like for example, if we give or if we feel all the data related to cyclone or related to any other natural calamity, then it can even forecast. From that data it will learn the pattern or behavior of the nature's some particular activity, and then it means it is able to use the existing knowledge, and then it is able to characterize the unfamiliar phenomena. For instance, a person can accurately guess the song's genre and potentially even the artist also, without a prior exposure to any particular song. The goal of AI is to fill the machines with the capability to learn and infer beyond the specific examples across the wide variety of topics. Any type of topic we can give, still AI, if the data is appropriately fed and machine algorithms are very much appropriately selected and optimized, then it is able to give us a very good result. A very good example of that is AI's Apple Siri. Believe it or not, it is responsible for more than just placing food orders. She can play specific songs on our phone, look up items on the web. It also start navigating us towards our destination. There are even things, if you likely ask Siri, that she has not been uh, done so far, still she'll do her best to arrive at the reasonable answer. So this is rather the thing which every one of us has experienced. Apple Siri or Alexa or many voice assistants algorithms. A popular subset of AI is a machine learning, which is why we often hear AI and ML as interchangeable terms to each other. Machine learning is the process by which computer can improve its own performance by continuously incorporating new data into an existing statistical model. So once we learn the machine learning algorithm, and then afterwards, if it finds something new, machine learning algorithm do update themselves. And we have seen this while playing computer games and all. When we play computer game, and if we just cross first few levels very fast, it will understand that the player is like a very prominent player or very good player, so the difficulty level automatically goes on increasing. Even in quite a lot of times in some competitive exams and all, the difficulty level also goes on increasing if first few answers are right. So depending on the user's response, or depending on the input what it senses, machine learning algorithms also can update themselves. One very good example I would like to elaborate over here, that is email spam filtering. A scenario is we receive numerous mail daily, and I wanted to automatically filter our spam emails from our inbox. A machine learning model initially is trained using a data set of labeled emails. So when I like devise a program, or when I make a program to filter these emails, I just tag those emails that spam and no spam, spam and no spam images, mails. So basically based on that, I teach that machine learning algorithm to sort out the mails. Then what machine learning algorithm does is, wherever I have written spam images as a label or a tag, it understands the pattern of the mail inside that spam image. Then what do you mean by a pattern? Pattern means the words comes inside the mail, or the word comes inside the no spam kind of mail. So in a spam kind of mail, some typical words like best offer, winner, lottery, U1 or some millions and billions of rupees numbers, something like this is written. So as a feature, it saves that, and then it tries to like do the operation. Now if sometime if I go to my mailbox and I see some spam mail in inbox which is not being filtered out, or which has been escaped, maybe very successfully escaped from the algorithm, and I mark it as a spam, immediately machine learning algorithm updates itself by the new pattern in that particular mail also. And that updating is what we can say machine learning algorithm learns from the data, and then it improvise, or it updates its own performance. That is what we can say a continuous improvement. So over the time, as the model incorporates more examples of correctly and incorrectly classified email, it becomes better at distinguishing between spam and no spam emails in a very better mode. Uh, Going ahead.
Excuse me, ma'am.
Yes, yes.
Ma'am, please make it full screen.
Actually, when I make the full screen, actually the slide doesn't go ahead. I don't know what is the word. Okay. Is it okay? I made it on the presentation mode.
Yeah.
Are you able to see it on full screen mode now?
It's okay, ma'am.
I don't know. For my screen, it's full screen mode actually. I can see full screen mode. So I think I will now shut off my camera so that bandwidth maybe can be utilized more in a better way for showing screen. Uh, with me, it's a full screen mode now. It's a presentation mode. Okay. Uh, okay. Well, there are two very important factors to the success of machine learning. First, more data, the better is our model. As it has more points to determine key patterns and behavior. For example, we were talking about spam emails, where when we have all those words, all possible words in the world, which makes any mail into categorized into a spam kind of matter, or the spam kind of mail, more better is our model. A machine learning model continuously improves its performance by learning from new data, thus becoming more accurate in filtering mail also. Secondly, the goal of building machine learning application most often relies on finding features or data that contain most helpful patterns. And the most helpful information is something like words, winner, best offer, you won, free, such kind of words. These are the data patterns. I can say these are the features of the particular mail to be categorized into spam or no spam. Because see, in a practical scenario or in a practical application, no mail will be tagged as a it's a spam mail, it's a no spam mail. It will be just a mail. Now what our machine learning program has to do, has to read that program. It has to learn or it has to read all the data patterns coming inside, and it has to see the typical way of the word or the patterns of the word coming inside, and then it has to make a decision. So sometimes it can also make some sensible mails into the spam mails also. So that these two factors, what I wanted to indicate over here, contribute in the success of machine learning. So the first factor is larger, more is the data, better is our model. But then again, computational complexity becomes a problem. And the second is finding features or the data that contains the patterns. So this is also called as, or this is also termed as a feature engineering. Feature engineering is also one of the process, or rather it requires a very domain specific knowledge, and which requires a very good human intelligence so that we can imbibe into the uh, machine learning intelligence. Now, going ahead to the next slide, that is deep learning. Deep learning is an advanced subset of machine learning that aims to mimic the way human brain learn and processes the information. It uses structured, means our machines. Okay, our machines uses structures called neural networks, which are designed to simulate the way neurons in the human brain activate and interact during learning and decision making process. So human brain analogy is being studied by the researchers and the scientists, and the way in which human brain is functioning, the very much similarity was tried to build for this algorithms. Here I have just given some pictures from that. I just wanted to illustrate one example so that learning process also would be simpler to understand. Suppose I have 1 3 4 year child with me, and I wanted to teach that child that how spectacles look. So initially, what many spectacles in the home or with the family members I have, I can show that spectacles to a child, and I can ask the child to understand or to learn that okay, this is the way in which spectacle look. So it has got geometrical shape on both the sides, and it has got that connecting lid in between, and the two longer sticks where which rests on the ear, and something like this I will teach the slide child. So in the learning process we can see that data input. Okay, neural networks receive the data, input data, which can be anything or from the text or images. Okay, then layer processing. Then in the child's mind, what processing happens? The data passes through the multiple layers, with each layer extracting higher level features and obviously lower level features also. So higher lower level features in this is what maybe a typical dimension only spectacles comes in. Then typically it has got this color. Then higher level dimensions can be the shape wise, only the shapes can be changed at these places from this and this. Then output generation, final layer produces the output such as classification or prediction. So if a child is shown one toy and a spectacle, because of the features of the spectacles are there in the child's mind, child is able to immediately differentiate between yes, it's a toy and it's a spectacle. Now if it's a deep learning kind of a model, if we imagine that a brain is a deep learning kind of a model where it is much more uh, great than the deep learning networks. Mm, then higher level features, when those are stored and the neurons are developed according to those features, then if unknown thing comes in front of a child after some years maybe, and which has got a very weird shape and very funny shape, or very party type of spectacles where two stars are in the place of round glasses, or some musical note sign, or some uh, pineapple or fruit shape, something some shapes are being shown to a child. Immediately those higher level features or those known things or those data inputs and those the processing within the layers immediately fires, and then these features and those features are compared, and from that the immediately a person or human being is able to understand that yes, even if it has got very less similarities, but because of higher level features, I can immediately identify that yes, it is a spectacle only. Only thing is different shape and different weird combinations. So this is what is the deep learning. So what are the benefits of deep learning? It the circuits are, or the algorithm implementation is more accurate. It is normally used for very much complex type of problem solving, and a feature extraction, which is nothing but, which we are going to talk about little later in the later slides. Feature extraction is something which is really making deep neural networks or deep learning process wonderful, or rather more user friendly, and rather more penetrating through each and every most of the applications in our day to day life. uh, okay, then understanding deep learning versus machine learning. Machine learning works well with the structured data, that is tables, fixed columns, 1D data, 2D data, something like this. Whereas it is effective for the problems with the limited number of features. This is also one of the thing in machine learning. And the traditional algorithms include decision tree, support vector machines, or linear regression. These are the typical machine learning algorithms. Whereas if you see the like workflow or data flow of machine learning algorithms, you see one object that is a car, then you have to do the feature extraction of it. It means how many like wheels it has got, then what kind of a typical shape it has got, because four wheels are there for truck also, bus also. So a typical shape, then the height, typical height, then the typical kind of features of front and rear views. These everything is to be extracted, or these first of all everything has to be crafted, and the program, separate programs has to be run for that particular features to be extracted, and later on those features have to be arranged in the structured way in some tables or in some excel sheets, and those excel sheets or table is to be fed for the machine learning algorithms, and then from those features the classification task is achieved, whether it's a car or a non-car kind of a object. Now when we go to the deep learning, which is a subset of ML that uses neural network to mimic the human brain, it handles less structured or more complex data. Now what we have to give over here is we just have to supply the image of the car to the neural networks in within the deep learning. Then neural networks are basically coming in both the places. In machine learning also we have neural networks, in deep learning also we have neural networks, but the differentiable point in the neural networks which are used in deep learning are thing about, like, one I have to very specifically mention that feature extraction and the classifications is both of the things are done within the neural network, and not much task of feature extraction and developing a classification algorithm separately is needed over there. These all things are getting done by deep learning. That is, feature extraction is also getting extracted by the deep learning. So obviously the time for doing the feature extraction or feature engineering process, for which the domain experts were required, is also been reduced, the cost is also been reduced. But then obviously at some places if you get something very, at some places you get some like very comfortable thing, the other place you have to pay a price to it. So the price to it is computational complexity, handling devices we need to have, then only these intense algorithms can be executed. So this is what is main crux, or what we can say deep learning. So deep learning, specific algorithmic approach to ML, where the algorithm used is a neural network, and machine learning works at the task level. So artificial intelligence, machine learning, and deep learning are working for to achieve same goals, but the approaches are different, and I can say the way of tackling the problem is a little different. So let's take one more example. We wanted to build a machine which would take the images, and which would be able to differentiate between the objects or the items, between the tomatoes and cherries. So I wanted to take pictures, or I wanted to, let's I can say it's a like hypothetical machine. So it will be able to, let's say it will be able to even separate out that physically tomatoes and cherries also. Anyway, the problem can be visualized. Then if it's a machine learning approach, what one has to do, one has to go for the features, like two features only I have written, and rest of all is just left for the thinking towards the user. So I can have one feature like a size. I cannot have a feature like a color, because in a color it will be definitely a jumbling type of thing machine will go into. So feature engineering makes some intelligence over here. So size maybe, or type of the stem maybe, and then what else features one can devise. Those all features could be a list. Then those features can be fed into machine learning. So that I have written over here that it needs a feature engineering. So that feature engineering is a cumbersome task quite a lot of times, and it used to be a cumbersome task quite a lot of times. Like whenever research work used to get carried out in terms of image processing or a speech processing, then we need to decide the features on our own. We need to write the programs which will extract the features, and then those features we have to arrange by appending zeros in the front or in the end, and then make all the features vectors of the equal size, and then feed it to the neural network, so that neural networks in the machine learning algorithms would perform better. Now in deep learning, just you feed the image, and then neural hidden layers inside the deep learning models adjust themselves. It means they adjust their weights and biases so that they can give the binary classification or the two type of class, one like two category classification. That's why it is called binary classification also, between the cherries and the tomatoes. Okay. Now, machine learning and deep learning can be like in the block diagram way, it can be represented like this: pre-processing, feature extraction, feature selection. Deep learning models are nothing but the models which does this feature extraction and feature selection altogether. Still, pre-processing needs to be done in quite a lot of times or quite a lot of ways, so that the effective classification can be done. Here I would like to mention some of the names of the machine learning algorithms that typically we use for solving the problems. That is k nearest neighbor support vector machines. Very popularly it is known as SVMs, decision tree, random forest, naive Bayes, linear regression, association rules, and k-means clustering. So these are the algorithms which work inside the box of feature selection and then classification. Feature extraction methods are different from domain to domain, because signal can be a 1D signal, signal can be a 2D signal like an image. 1D signal means, example is a speech signal, it's a 1D signal. Image is a 2D signal. Then we can have some 3D signals also. So based on the signal, based on the characteristics, and based on the patterns of the input data, it can be a text signal also. Not a signal, we can't say text signal, it can be a text input also. So based on your input and depending on the kind of data we wanted to process, pre-processing is required in the different forms and the ways. Now the thing comes, like now we have seen that okay, deep learning is a good one, or it's rather a good thing where we are not supposed to run behind extracting features manually. The scenario seems to be very comfortable. So like what are even the things when we have to apply, or when we apply deep learning, or what are the scenarios where we apply deep learning algorithms. So for that purpose, we can say that machine intelligence is useful in many situations, which is equal or better than human experts in some cases, meaning that DL can be a solution to the following problems. Problem number one type is cases where humans are unable to explain the decisions made using their expertise. So it is nothing but language understanding, medical decisions, and speech recognition, like, or speaker recognition also. Like for example, when we hear our mother's voice on telephone, even if her name is not displayed on the screen or her number is changed, immediately within one or two words we are able to identify that yes, it is my mother's voice and this is my mother speaking with me. So these are the cases where human are unable to explain the decisions made. Even my mom is like having some cough and cold and her voice is little bit changed, still I will be able to understand. Maybe this time I will require 3 words, otherwise I'll require only 2 words from her, that for recognition that yes, she is there on the other side of the phone. So such complicated cases where very effectively the mathematical model or mathematical equation can't be put, that a plus b is equal to c, something like this. Those are the scenarios where deep learning works very well. Point number two, cases where the problem solution updates over the time, that is price prediction, stock preferences, then weather prediction and tracking. Like object tracking or person tracking or human tracking somewhere, even in inside home also, if you are tracking somebody going here and there and you wanted to turn off lights. So these are the problem solutions which keeps on updating, because inside home light intensity will be different every time, then inside home the other conditions will be different. So and the very popular example is stock preferences. Many of the companies are running behind developing a model which will forecast the stock market, so that and they are running behind like putting all the parameters inside that algorithms, so that predictions would come better and better and more close to the actual things which are happening after few days after being prediction is being made. And if a huge thing like a stock prediction, if it is taken, definitely it is a solution which is updating over time. Economical, many parameters comes into that, war happening or not happening, something in some region even comes into that, and many other geopolitical or geosocial things comes into that. So these are the cases where definitely data is also very huge and it keeps on updating. So there it is very difficult to do the feature engineering and all. So deep learning proves to be the very effective solution for that. Point number three, cases where the solution require adaptation based on the specific cases. So personalization and biometrics. So biometrics definitely need some type of adaptation. Even if I give, like, if it's a retina scan or if it's a thumbprint, then it may not be that very significant. But otherwise, biometrics requires the adaptation for face recognition and for the other recognition system. The last point is cases where the size of the problem is extremely large and exceed our inadequate reasoning abilities. That is what I can say: sentiment analysis, matching ads to Facebook, and calculation of web page ranks. So sentiment analysis is, again, it's an extremely large or extremely rather wide area where the work is getting done. And in that sentiment analysis, not only voice, it's a multimodal signal system, not only voice, facial recognition, facial gestures, even the body language, and it's a multimodal kind of signal. So the many signals are analyzed, and then the sentimental or emotion recognition is being done, or somebody's panic, or somebody's uh, requiring psychological help or not. This decision can be taken automatically by the machines, and corrective actions can be taken to improvise the quality of the life in a better way. So these are the scenarios where we can apply deep learning models, and deep learning models even proved to be very nice, giving a nice performance in these scenarios. Now, if we want to just see the frameworks and data sets for the deep learning. So, several deep learning frameworks and data sets have been developed in the last few years. Various frameworks and the libraries have also been used in order to expedite the work with good results. Uh, though their use, the training processes has become easier. Table next lists the most utilized frameworks and the libraries for deep learning based on a star rating on a GitHub, as well as my own knowledge in this field. TensorFlow is deemed to be the most effective and the easy to use framework. It has the ability to work on several platforms also. So let me just show you these some like things I have enlisted. There are lot many even other than this also, and day by day many new things keeps on coming. So I just keep it for you, just 2 minutes there. You can just read it once, because many of you are using that, and many of us are even knowing this, like TensorFlow, which is or run on the Apache server actually, and the core language, it's C++ and Python, and where year of release is 2015, where Keras runs on this MIT openware server, which is core language of that is Python. I just want all the audience to just have a look at that, because we are maybe knowing one or two, or maybe we are working with three or four, but these many options are available. Mostly Torch server, I personally have used for speech related application, because Torch server is, sorry, Torch framework, I'm sorry, Torch framework is very good in supporting speech related applications, because speech is a time invariant data. And when the data is time invariant, then the processing is little bit different, and speech is a homomorphic signal also. So speech is a convolved signal, rather we can say. So like a image is a multiplicative signal. So you have a multiplication of two things. Now, if you just take a DFT of that, you get the additive signal, and then you can just take, like, you just take a log of that, then you get additive signal. And just filtering additive signal, filtration of additive signal is very easy, but convolved signal is not having the way back in reconstruction. Once you do deconvolution and then again you try to convolve that deconvolved coefficients, you don't get the original result. So it is called homomorphic signal processing. For that purpose, torch framework is a very good framework, and according to everyone's experience, different frameworks are proving to be good in different applications. Now, going ahead, uh, with this, I just wanted to now here show that typical DL workflow to DL is deep learning workflow to solve real world problems, which consist of three sequential stages. First stage is the data understanding and pre-processing. Am I audible? Hello? Hello? Deepak sir, am I audible?
Yes, ma'am, audible.
Okay, okay. So the
Audible,
first
ma'am,
step,
audible.
yes, yes. Thank you, thank you. First stage is a data understanding and pre-processing. Second stage is deep learning model building and training. And third stage is validation and interpretation. Validation and interpretation, moreover, remains same for artificial intelligence algorithm or machine learning algorithm, because these altogether represents the performance analysis matrix and model interpretation and conclusion drawing. So the step number one, if we see the as the DL models learns from the data automatically, we need not like have to extract the features of the data and feed the data. So an in-depth understanding and representation of the data are important to build the data-driven intelligent system in a particular application area. Um, in the real world, data can be in the various forms. So data can be in the various forms. Uh, Now that data can be a sequential data, 2D data, or a tabular data, or any other type of data. So let me just just give you a brief about these type of data. When we talk about, or when we say a sequential data is any kind of a data where the order matters. That is a set of sequences. It means text streams. If I say hello, how are you? Then this text stream is very much important or very much meaningful only and only when the sequence of the words have been kept appropriately. If I jumble up all the sequence of the word, then it becomes meaningless or the data loses its meaning. So sequential data is what you can say a set of sequences. It means a text stream. Audio data is also a sequential data, or speech data or audio data is sequential data because it is a 1D data and you can store it in a one-dimensional array, one after another samples. If we just missed few samples here and there, then voice would, like when the voice is reproduced, it would sound like very weird voice or something different only we can uh, hear. Then time series data is also a sequential data. Then going down to the next type of data, that is nothing but a image data or a 2D data. Image data or 2D data means a digital image is basically made up of matrix, which is a rectangular array of numbers. So when we like talk about image, like it is 1024 by 1024 image, it means it's a 2D data. It is a matrix representation of the data. Then it's a tabular data. Tabular data set consists of primarily rows and the columns. As in database table, you can imagine Excel sheet in front of you. That is a tabular data. Overall, it is logical and systematic arrangement of the data in the form of rows and columns that are based on the data properties or the features. Deep learning models can learn efficiently on the tabular data also and allows us to build a data-driven intelligent system. Okay, so this is what is the first step to be understood, that is data and what kind of data. Then if we are talking about the data, one interesting thing I would like to highlight over here about the amount of data. We have just seen the type of data. About the amount of data, if I have to speak, then this is very self-explanatory graphs of the performance analysis of machine learning and deep learning algorithms. So if we do the performance comparison and if we see the amount of data fed to a deep learning algorithm, if it is increased and increased, the performance also goes on increasing and increasing. I won't say a very linear relationship, but still it is on the increasing way only. But if you see towards the machine learning algorithms, after a certain amount of data, its performance increases, and later on the performance becomes subtle or stable. The performance, if suppose that performance has reached to 80% of correctness of the decision or of the prediction, then it doesn't increases much more after 80%, even if you increase the data feed to that machine learning algorithm in a very huge way. So I can say because of that only, like overfitting problems are quite a lot of time described, and overfitting and underfitting, these are the two problems we face in feeding the data if we don't pay very much careful attention to the data or its features rather. Because in machine learning we cannot say that data is feed. In only deep learning we can say the data is feed to the network. In machine learning, data is never feed to the network. Machine learning algorithms are not able to read any data. Machine learning algorithms read only the features extracted from the data, and then it works on those features. So this is what is about the data. Then if we see step 2, that is model building, then learning types, if we see over here, it is a discriminative, it is a generative, and it is a hybrid. So GPT is a generative model, and then discriminative models, that also some good explanation I have in further slides. And hybrid is something like you take two networks together, like convolutional neural network and LSTM network. If these two networks are combined and then a data is feed to that, the combined result can be seen. And nowadays rather it is more trend to have the hybrid networks, so that the, I can say, drawback of the one network can be overcome by the another network, and then they can be supportive to each other, and obviously the performance is better. Performance may be better. We cannot say every time performance is better. Then obviously the tasks are very same: prediction, detection, classification in machine learning, deep learning, or AI, or anywhere. Now here I would like to mention deep learning methods. Like I mentioned in the previous slide, machine learning methods like K nearest neighbor, then naive bias, and so on, SVM, and many algorithms I mentioned there. Here the algorithms are MLP, like multi-layer perceptron convolution neural network, recurrent neural networks, then GAN networks, AEs, autoencoders, DBN networks, DTL networks, and then hybrid means AE plus CNN, and so on. These are the algorithms, or we can say these are the methods. Algorithms are nothing but the method to do something only. So these are the deep learning methods which we implement so that the task can be achieved. And then step 3 is a validation and interpretation. Okay, so going ahead now. Okay. Now, key dependencies of deep learning techniques that are needed to take into account before started working on DL modeling for real world application. So this slide reveals that deep learning techniques are dependent on few things. It is not the case that yes, everything is good in it. Like we all know that everything cannot be good if the algorithm is very big and very extensive. It may be solving a problem very greatly, but it requires a more memory and it requires a more computation power. And if the algorithm is small and fits within the very small size of the memory, then it may be giving us the solution for a simple type of a problem. So it is never a win-win situation. It is always a golden mean between what we want and what we can have. So the deep learning methodologies or deep learning techniques even seems to be very lucrative or very fascinating for implementation for the complex problem. It has got some dependencies for the performance or for the for giving you the better performance and for giving you the better efficiency, those dependencies are listed as follows. The first dependency is something on the data dependency. So when the data volume is small, deep learning algorithms often perform poorly. This is very interesting thing to understand. In such a circumstances, however, the performance of the standard machine learning algorithms will be improved if the specified rules are used. So data dependency has to be seen in this way. If data volume is small, then machine learning algorithms would rather work well, where machine learning algorithms are specific rule based or specific like formula based or function based. And deep learning networks are very data extensive networks. If you have extensive data, then it is very like you can say good scenario for you to select deep learning network and implement deep learning network. But obviously the second dependency immediately comes in the picture, that is hardware dependency. In the hardware dependency, we can say that deep learning algorithms require large computational operations, while because it will be extracting features also, it will be doing classification also. So large computational operations are required internally, and obviously it works on the large data sets. So as a larger the computations, obviously the advantages of the GPU over CPU comes in the picture, and the GPU is mostly used to optimize the operations efficiently. Now I can say that thus to work properly with the deep learning training, GPU hardware is must. Therefore, I can say the deep learning algorithms relies on high performance machines than standard machine learning methods. So this is a hardware dependency. It means like if you have a relevant hardware, then definitely you can get the good performance from the DL. But if you don't have that hardware, then obviously DL will underperform. It will not outperform. So these algorithms efficiency depends on hardware. Next is the feature engineering process. Feature engineering process of extracting features means extracting some typical characteristics, extracting properties, extracting attributes from the raw data using domain knowledge. A fundamental distinction between DL, as we have already discussed, and the other machine learning technique is the attempt to extract the characteristics, that is high level features, directly from the data. Thus DL decreases the time and effort required to construct the feature extractor for each problem. That is what is very rather you can say a positive point in terms of these dependencies of the deep learning algorithm to work efficiently. Then comes down is like many researchers talk about this nowadays quite oftenly, that is black box prediction and interpretability. Now black box prediction and interpretability, when we talk, I just want to take you back to this circuit or this block diagram, where I can show only one box over here. That box is like deep learning model. You don't know what are the, I'm sorry, you don't know what are the features inside this. You don't know which features are extracted. You don't know what it is doing. So that is what is getting termed over here as black box perception and interpretability. Okay, so black box perception and interpretability, um, it is a factor comparing with like always this comparison between DL and ML about these factors getting done, and it is very difficult to explain how deep learning result is obtained. So it is a black box. On the other hand, machine learning algorithms, if you see particularly rule-based machine learning techniques, provide explicitly logical rules, and we have a very explicit and tight control over the algorithms running. Like we only write the statement something like if, then, if else, for making the decisions that are very easily interpretable for the humans. For instance, in some earlier work, um, we have seen several machines which are learning or rule based techniques, where the extracted rules are human understandable and easy to interpret, or easy to update or easy to delete according to the target application. But due to this black box perception and rather very low interpretability or very low visibility that what it is doing internally. We don't have exact control, or we don't have the explicit rules over which the system is running. And then the problem comes not in system running. Problem comes sometimes when we want to update, when we want to delete some part of target applications. So that is one more dependency. Then model training and execution time. So if we talk about the model training and execution time, training in the deep learning algorithms obviously take a long time, because that algorithm only has to extract features, only has to build a classifier or build a recognizer like pattern recognition, pattern classification, and something. The model training process takes very much longer. For instance, I have seen DL models can take more than 2 to 3 days to run. So you need to have that whole arrangement that power shutdown should not be there, power fluctuation should not be there, machine should run in a environment where they will not get heat much, and they'll run appropriately. Because for a longer time, like 2 to 3 days, they will be continuously running and updating their weights and their biases and their many other parameters also, so that they can do the specific task. Where machine learning algorithms takes little time, only few hours to at the most a day. During testing, deep learning algorithms take extremely little time to run as compared to certain machine learning models. This is also very interesting fact to see, that while training, while training, it takes such a good amount of time, but in testing mode or in the testing way, it takes less amount of time, and it gets trained in the, sorry, it gets tested in the less time. Now, going ahead is a taxonomy of the DL techniques, that is deep learning techniques. There are three major categories in the deep learning technique. Like in the machine learning techniques, supervised learning, unsupervised learning, then reinforcement learning. This is what you can say a taxonomy in which machine learning algorithm work. So a DL algorithm works in the taxonomy like discriminative or supervised models. In previous slide, we have seen somewhere discriminative type. So the second is a generative or unsupervised type. So here also the same thing, but the nomenclatures are little different. So this is generative or unsupervised. Then next is a hybrid learning, where I just mentioned that in the previous slide only, that different models of different models of deep learning techniques have been taken, and they are combinedly uh, like arranged to work for some problem solving. So supervised learning, multi-layer perceptron, and convolutional neural network, and recurrent neural networks. Then in recurrent neural networks, it is further classified into LSTM. LSTMs are circuit which works very good for the speech signal, or you can say sequential data or 1D data. Then GRUs are nothing but the gated recurrent units. Commonly used deep neural network techniques for unsupervised or generative types are generative adversarial networks, GAN, autoencoders. Autoencoders are running like nowadays, they are like capturing almost all the applications in a very effective way. So autoencoders, then restricted Boltzmann machines, RBM machines, then self-organizing maps, that is SOM, deep belief network, DBN, along with their variants, self-organizing maps. Uh, these are the few options available for us under the unsupervised learning. Most of the times in deep learning techniques, one can see that the problem statements are unsupervised type statements, because whenever there is a huge data, whenever there is a massive data, you can say, so at that massive data and at that huge data level, it is very much impossible to have the probability that data will be tagged or data will be labeled. So if the data is labeled, we all know that we go in supervised learning mode. But if the data is unlabeled, we have to understand the pattern, we have to understand the one typical type of way of existence of the data. Then it is most of the times unsupervised kind of a learning, or unsupervised or rather unlabeled data. The third one is not very differently explainable because it is just making the combinations, good combinations of two things. Okay, so it is taking, let's say while building a vehicle, it is taking the mileage of two-wheeler, and it is giving you a comfort of four-wheeler. If something like this is being made, what can be a product one can imagine only. So that kind of thing people are trying to make, and obviously people are getting success into that also. So these are also approaches nowadays very much sought after and very much implemented after. Now, deep networks for hybrid learning, and like this about the last network, that is hybrid learning. I just wanted to talk about that. Transfer learning, basically deep transfer learning and deep reinforcement learning. Okay, these are the again two methods in deep learning which people are implementing. Deep transfer learning basically is a technique for effectively using previously learned model knowledge to solve a new task within a minimum training or fine tuning. In comparison to typical machine learning techniques, deep learning take a large amount of training data. As a result, need for the substantial volume of label data is a significant barrier to address some essential domain specific tasks. As I told you, deep learning models normally chosen for the problem where the data is massive, data is extensive. For example, predicting the stock market price tomorrow. So there is a massive data one has to use, and when the data is massive, more likely the data is unlabeled. So particularly in the medical sector or in the stock market kind of a sector where creating a large scale and high quality annotated data is very difficult and very costly. If you take a data for share market and try to tag it, then it is a very huge task. It's not possible, rather through the programs also, and it's costly also, obviously. Furthermore, the standard DL model demands a lot of computational resources also, such as GPU enabled server we need. Even though researchers are working hard to improve it, as a result, deep transfer learning thing comes into the picture. So a deep learning based transfer learning method, it is helpful to address the issue of used data and unannotated data or unlabeled data. It shows the general um, it shows the good behavior of the transfer learning process where the knowledge from the pre-trained model is transferred into DL model. And it is especially popular in deep learning right now since it allows to train the deep neural networks with very little data. So deep transfer learning is something um, like today's session, you can say. Okay, transfer learning, today's session. So if we consider one audience who is not at all having any background, then learning sitting for the introductory sessions makes some kind of space or makes some kind of environment building into the mind of the person. And then whenever the person goes for the further classes, obviously that pre-trained brain or pre-trained neurals definitely help the person to grasp the things with a faster rate and grasp the things in a uh, like less time or in less um, or less efforts, teacher telling in less efforts, the person can understand. So that is what you can say deep transfer learning. The models are already pre-trained for identifying some typical patterns or some typical features of the data, and then later on whatever data you want to make that um, thing learn, like for example, I'll give you an example only. For example, I wanted to implement the handwritten text. So priorly the models are trained at the facility where very good GPUs are available and good power, huge amount of data is available. The model is already trained to understand the handwritten language. Like if a model has to understand how the 8 is written, already 10, 15, or maybe 50 types of 8, how it is written, it's been already fed into that. Okay, so it's been ready that yes, I know what is the digit 8, I know how it is written, one circle and below to that one more circle, and I know how variably people writes it. So if I just take that pre-trained model, and then AlexNet is a very popular pre-trained model many people use, and then I train that pre-trained model for few sets of 8 in which I have a data, then it will very immediately learn that, because its weights and biases are very much tuned to understand that particular figure or that particular pattern, so that within very short amount of time it will uh, like we can say it will learn. So if we train our student, if teacher is delivering some content in the class and the students are learning that, and afterwards when they go in industry and they work there, obviously that pre-seasoning or pre-training makes the task little more easier. So that is what is deep transfer learning. Then comes down to the reinforcement learning, which is also a very one of the very important part in deep learning. Rather, many a places now 50% of the applications are showing the properties of reinforcement learning. Now, what is reinforcement learning? It is basically a very different approach to solving the sequential decision making problem than other approaches we have discussed so far. The concepts of an environment and an agent are often introduced first in the reinforcement learning. Okay, environment and agent means what? For example, environment means if I'm playing a game, so the surrounding around me is an environment. And agent is what? Some character is playing or some character is running, and I make that character to jump. I make that character to collect the coins. I make that character to do something so that I get reward. Is nothing but what we can say agent in this example. Okay, so the agent can perform the series of actions in the environment, each of which can impact the environment's state and can result in the possible rewards, that is feedback positive. Okay, so if some action is being taken by some environment, like for example Facebook, when I open Facebook I see the relevant advertises to me, and for that relevant advertises, if I click on that advertise of a particular product, and then I am redirected to the particular website, and if I purchase that product from there, the algorithm gets updated. This is reinforcement learning. Algorithm uh, takes that as a reward, that yes, I have shown this ad to a person, and from some certain logic I have shown this ad to a person since she is a female and she may be interested in these three four five typical things which she might immediately buy, and I have shown those ads at a very exact time and very exact date, and then she purchased it. So this is the purchasing at the good of the good at from that website gives the rewards to that algorithm which is showing you the particular advertisements, and from that it makes the things more clearer, or rather more strong, that yes, whatever was logic was used, that logic is good because it is working. Sometimes it might happen reverse way also, it is showing me some advertise but I am not even looking at it, I am just scrolling it. So amount of time you are waiting and looking at some object is also been recorded in the background of the apps. So if I don't look at that, so again it's a reinforcement learning. The algorithm gets the reward in terms of updating itself that she is a person who does not see the ads of these items because she is not interested. So next time those advertises are shown in the less uh, number. So this is a reinforcement learning. That means in reinforcement learning, there is an environment and there is an agent. Now here, who is agent? I am agent because I am taking some action. I am going to the Amazon website from Facebook and then I'm purchasing over there. So depending on the agent doing the actions, the algorithm is updated so that further the performance of the algorithm is more better. People are more trapped and they are more thrown into the trap of purchasing many goods. So in this way, deep networks for hybrid learning and other approaches. Now coming down to, excuse me, just a second. Now coming down to a slide where I have just mentioned application areas, and those application areas involves many tasks and the methods which people have successfully implemented. These are the methods taken from renowned papers from IEEE and Springer and elsewhere publications, where people have claimed that they have achieved a very good efficiency. And I just leave this slide for 2 minutes for all the viewers to see and to understand that how the work is getting done and in which applications, what kind of networks are getting used. Like, so what I was saying about the natural language processing or speech emotion classification, speech recognition. So that time I was mentioning that LSTM happens to be or proved to be a very best network. It is mostly used in speech related applications. Since my domain of research mainly in speech, I have came across or I have used this network, so that immediately I can tell. So many people working in different domains also might have observed that these all combinations are used. Like here we can see IoT and smart cities applications, smart parking system, convolutional neural network and LSTM based uh, algorithms are used so that we can implement this tasks. Can participant mute the mic? Okay. Uh, Deepak sir, whose mic is like accidentally remain open, can you just let them know, please?
Miss, your voice is not audible to us.
Hello, is it audible now?
Yes, miss.
Okay. There are so many algorithms and there are so many methodologies with which deep neural networks runs. So I would be like just taking one of the very interesting method, that is convolutional neural network. So just let's begin, and in a very short time we can see the beauty of the algorithm and we can really appreciate the researchers who have developed such a beautiful algorithm. Let's go to CNN. In CNN, let's take a very simple task of pattern recognition. If I draw O or if I draw 0, let's say anything, 0 on the screen or on the paper, and then an image is feed into the and the image is taken and is feed into the computer, and that is what, if we see the pixel wise, the O looks like something like this. And if you see the pixel size or the pixel value of the picture or the image, let's take for example 6 pixels wide by 6 pixels wide. So it is 6 by 6 image. Practically speaking, 6 by 6 image may not exist also nowadays. It is in some K dimensions nowadays. But just for example, 6 by 6 pixels, then it is possible to make a normal everyday neural network that can correctly classify it. Not a CNN is required, but for example, everything is fine. Now what I have done over here, I have created 1D data from this 2D data. This image is nothing but a 2D signal which has got rows and columns. Now you can see that this zero, first zero is written over here. Then second zero is written over here. Third one is written over here, then one. So likewise, this complete row is first of all written as a column, then second row is taken, then it is written as a column. So in total, it is 36 cell array. That is obviously 1D array, or it has become a sequential data. Now, when I feed this sequential data to the input of neural networks, input of the neural network, just read all these values. This green line indicates that these are the connections from where these all zeros and ones feed inside, and there will be a summation taken at this point, and then plus some bias value is added. Okay, this bias value is required for like making this summation to go in like one particular class, like it goes above zero or it goes below zero, something like this, because all the values are zeros and ones. So sometimes it is not exactly not even more than one, or it is rather zero. So we want some values to be lesser than zero, and we want some values to be greater than zero, so that some bias is added, so that some different numerical values we can get, because we wanted to classify, or we wanted to have the structured classification of the numbers, of the features, you can say. So after that, this is a activation function. This function is ReLU function, and this ReLU function shows you here what, see, you can see this gray line. The gray line is zero and gray line is this what's slanted. So zero means if any value like sum plus bias, okay, suppose sum is 0 plus bias is 2, the total value becomes 2. So 2 is what? From 0, 2 is on this side. So if 2 is over here, then correspondingly output is, let's say, 2, because it's a linear relationship. Na? So if it's 2, let's say it's 2. So output is 2. If a sum is 1, then the bias is, if the bias is...
Miss, sorry to disturb you. Can you again tell me means what we have considered as a bias?
No, see, now in this case, biases and the weights are something which are initially some randomly weights and biases are being taken. Okay, so randomly any random generator function we can call, and from that any random number sequence we can take, and biases can be feed accordingly. Okay, and then the outputs are seen. Okay, so if and then when my output is not according to the required output, then again the correction in the bias is being done. It means bias may be updated by one value up, and then again output is seen. If it is not appropriate, then again biases are modified. Again it is decremented, because after incrementing I'm not getting appropriate output as I wanted to have. Then again biases are updated in the reverse order, and something like this, try and error, up and down, doing like that. Then finally somewhere I get the true bias value, which will be very nice value, or which will be very good value, so that I can classify the particular image as a particular class. Like this image is to be classified as what? This image is to be classified as image of a 0. If it is classifying it as something else, then I need to adjust my weights and biases. Okay, so like for example, I'm starting from Delhi and I wanted to reach Pune. Randomly, I cannot randomly if I start, then after traveling some time, I will see where is my destination and where I am. So destination and myself is found to be having a more distance than the original destination of mine. Then I can immediately conclude that, oh, I'm moving in some reverse direction, because original destination, original source and destination was having, let's say, 150 kilometers, and now it is showing 160 kilometers. Means I am doing something wrong. So I need to again correct that. And so the things are getting corrected. And then again, it is traveling. Suppose I am again traveling from Delhi to Pune, some distance. And after 1 hour, I check how much distance is remaining. If it shows me that 120 kilometers are remaining, means I can decide that, yes, I'm going in the right direction, because gradually the distance is decreasing. What this distance is nothing but the error signal. That error signal, how it comes from the system now, just remove the example of Delhi and Pune. How this error signal comes? Error signal comes by taking the subtraction between the actual outcome and the exact outcome what you want. So if it's a difference more, then you say that no, the networks are going in. No, rather in deep neural networks, we don't have to say no. The network only updates itself. We just have to tell the network that error has to be 10%. So if error is more than that, it just changes its bias and weights. And so that only it takes so much of time to learn. Why it takes so much of time to learn? Because randomly first it takes some bias value. Later on it checks the output. And then if the output is not proper, it updates itself. So that time is required in this whole process. Okay, so let's go ahead once. I hope I told you what you were like having a doubt on.
Yes, miss. Thank you.
Random number. It may be 0.7, it may be 0.43, it may be 1.43, it may be 2.97, any random number. It is not rather fixed. And a deep learning networks has got that black box anatomy, no? So we never come to know that what it was. But in machine learning algorithms, we can see, we can modify, we can start with very good optimum set of bias and weights, so that learning also becomes like speedy. But in deep learning, it's a black box. You never know. But only thing is, you know, is what is happening, like how it is happening and all. No, you don't know. Rather, you can say how it is happening. We know. What is exactly happening, we don't know. So it's a black box kind of thing. But it's very interesting to learn and know. The next thing is, again, if we have the second node of neural network, then again, all those zeros and ones feed to that point. Then again, some different bias. And then again, it has got a different function, activation function. This activation function basically is, you can say it's acting as a threshold function. So it's a threshold. Below threshold some value, it is categorized into first class. Below, above threshold some value, it is categorized into second class. So for that categorization, something we need to have. Otherwise, we would be jumbled up with so many numbers. So we need to have threshold. 0.5 के नीचे कुछ है तो वो इस कैटेगरी का है, 0.5 के ऊपर कुछ है तो वो इस कैटेगरी का है. ऐसे करके हमें वो थ्रेशोल्ड चाहिए. Then next is what we do, the process from which the name convolutional neural network has came. So this is what is a filter, digital filter we take, and the filter size is obviously always less than the original image size. Here original image was 6 by 6, where the filter size is 3 by 3. And then this is the pattern inside the filter. Now, who has decided this pattern? Again, this pattern is randomly also decided. So after doing so many iterations, even the correct filter pattern is also getting decided, which gives you output, which gives you correct output, or rather which gives you output within the required parameters. So let's say this is one filter. What this filter is doing, this filter is kept over the original image, now which is seen on the next. This filter is kept over the original image, and then the digits are multiplied. Now how the digits are multiplied, you can see over here. The first 0 is multiplied with first 0. This 0 is multiplied with this 0.
Madam, your yes, slide is not visible.
Oh, slide is not visible.
Please share it, I think.
From my side, it is visible. Deepak sir, should I log in once again?
Yes.
I think okay. Share. Now is it visible?
Yes, it's now visible.
Okay. So here we have taken original image where O is written, and our aim is to identify it as O. Okay. So there will be two classes we are discussing about. Either zero will be zero, means circle will be written, or there will be a X like cross. Okay. So let's say this is a O. Now this filter is kept over this. Then the first computation is nothing but multiplication of this zero with this zero plus this zero multiply with this 0, then 1 multiply by 1, 0 multiply by 0, 1 multiply by 1, something like this is carried out completely, and then you can see the calculation looks like this. Okay, these positional values are written, this 0 with this 0, something like this, and then if you add this up, obviously it's a simple multiplication and product. This is product, this is sum of product. So the answer comes down to be a 3. So once this answer is 3, this process is called a convolution process. So this algorithms are given names as convolutional neural networks. Internally, these neural networks are doing all these computations and everything. Okay, now this 3 is taken, and then this 3 is added with some bias. In the previous slide, madam was asking about a bias. So here randomly a bias is taken as -2. Okay, so this 3 is then added with a bias -2, 3 minus 2, the thing becomes 1. Now the next step. In the next step, now this filter is slide over the image by 1 position. The filter was initially here, and then it has been slided by the 1 pixel position. Now filter is on this position, and with this position we can say that rather we can again do the very same thing. We can again multiply the things, and we can again produce the same kind of result. Like here now, multiplication of 0 into 0 plus 1 into 0 plus 1 into 1 plus 1 into 0 plus 0 into 1, and so on. So after this, what we get is the answer, whatever is the answer, and that particular answer is then done with this bias, this answer plus -2, and the next number comes out which falls down over here. So if we do that shifting of like filter on the main image in the horizontal way and later on in the vertical way, so what we'll get, and after adding a bias that is -2 everywhere, what we get is this so many numbers again we have got. So these so many numbers are nothing but a typical features for the particular image. What we can see in this typical features, this 1 and 1 positive values, and rest of all are the negative values. Okay, this is what is the activation function. What this activation function here tells, the values which are below 0 are 0 in the output, and values which are above 0, they are having the output in the particular uh, linear fashion. So this one will turned out to be 1 because it's a linear relationship, 1 to 1, 2 to 2, 3 to 3, and all these negativities will be having 0 values, and the last one will be given as 1. So it means that all the negatives are set to 0, and that is what is a function. This what activation function plays role, that it defines, it creates a threshold, and below threshold 1 value, above threshold another value it sets. Otherwise we can see over here lot many values we have to deal with. So other to that, we have to deal with here only now 2 kinds of values. So this is what is the activation function. Then next comes is the feature map to this. In this case, it means everything sets to 0 except for these 2 points. This we have already discussed. Let's go ahead. Okay. Now, the next step comes, which is called as a max pooling. In this step, this is what is a feature map. What we have got. What was that? That was 1 and 1 over here, and everywhere 0 0. Now in max pooling, again, what they do is they make the window of 2 by 2 pixels, like a 4, and then out of this, like let's say a pink window, they take the maximum value out. What this maximum value is 1. Out of this gray window, what is maximum value? 0. Out of this blue window, what is maximum value? 0. And out of this yellow window, what is the maximum value? 1. That's what it and this is the filter usually moves in such a way that it does not overlap itself. Now this filter does not overlap. If this 4 are taken, then distinct 4 are taken, then different 4 are taken, different 4 are taken, and then maximum values are pulled out. That's why it is called max pooling layer. Then after max pooling layer, then we have select a maximum value in each region. This is called max pooling. So going ahead with that, now what we can see is whole this image is now converted into only 4 bits, that is 1 0 0 1, and this is max pooling step is selected, the spots where the filter did the best matching in its original scanning of the image. फीचर मैप में आप देखेंगे यहाँ पे 1 था, यहाँ पे 1 था, मैक्स पूलिंग में वो फीचर रिटेन करके बाकी सारे फीचर्स को बाकी सारे फीचर्स के साथ मैच किया है. So max pooling layer is something like this. And now sorry, and now this is what is the max pooling step. Okay, so coming down to after that, then now we have these all 4 inputs. From where this has come? This has come from the max pool layer. 1 0 0 1. This is a 2D data in rows and columns. I made it 1D data. This is 1D data, that is 1 0 0 1. Now these are again the biases and the weights at which goes in the calculation like this. 1 multiplied by minus 0.8. As I told you, these triangle values, this keeps on updating unless and until your circuit converges to the right output. So 1 into minus 0.8, 0 into minus 0.7, 0 into 0.2, 1 into 0.17. These are all like weights. The final bias is added to it, that is 0.97, and the answer comes out to be 4. Okay, so 0.34 is greater than 0. Yes, it is a greater than 0. So in this final activation function, what this function is evaluating f of 0.34. So f of 0.34 is 0.34 because it is having a linear relationship. All the positive values which are greater than 0 having the linear relationship, means if a value is 0.34, output is 0.34. If the value is 2, output is 2. If a value is 3, output is 3, something like this. So the output is 0.34. Now that 0.34 value output comes out from this activation layer, an activation function, it goes over here. And again, one more calculation is getting done over here. Okay, it is multiplied by the weight, again 0.34 into minus 1.33. This is again a weight which is set by neural network after so many iterations. Okay, or maybe it's a first iteration also. We never know about what iteration we are speaking about. Okay, we are only speaking about one iteration. That may be 50th iteration or maybe first iteration. Okay, but this example was the 50th iteration because it is showing the right result. So this value multiplied by weight, added bias into it. Again, 1.45 is a random bias and output is equal to 1. So see, in this, what we know 0.34, we know 1. So neural networks find out on its own that what best value at 1.33 and 1.45 would be, so that it will give you output 1. And to decide upon these values, neural networks takes time. That is what is we can say a learning time. Okay, so we know output, we know input, and we don't know in between, so that the input can be converted into output is equal to 1. Okay, so this is what is 1, and so the input image is classified into class number 1, which is circle. Now the another is the cross, which has been just cut over here. The another is this cross 0.34. Downside, you can see the weight and the biases are different, 1.33 and 0.45. So it is 0.34 into 1.33 plus like input multiplied by weight added with a bias gives you the output. So this bias is selected in such a way that output should come 0. Input we have, whatever input we have, then whatever output we want. So in between, just adjust the values so that the required output comes. So the required output comes if for this 0, then what we can say that this is nothing but a letter X, not letter O. This is a binary classification because the classes are only 2. So in this way, what I can say that this is a complete slide of the total operation. In this way, I can say that this is the original image. After that, it is convolved with this filter. Then this filter output is added with some bias and a feature map is being taken. This feature map has got lot many values. Here it is only showing 2 and 1, but in actual practice 0.32, 0.42, 0.51, something like this, whole set of different values, and it's very difficult to deal with all different values. Then activation functions aggregates all those values into 2 classes. So this is what you can say is a 2-class network, 2-class matrix. In that 2-class, scaling is done. So out of 2 by 2 or maybe 3 by 3 or maybe 4 by 4, it depends on again neural network how it decides. It decides on its own. We don't come to know in the deep neural network technique. Then max out of that, and it just plays it. Then the signal is 1D is being made, multiply input, multiply by input is in our hand. No, input basically comes from me. So I have an input, I have an output, and then in between values will be decided that the output comes from the required input. I have 5 in my hand and I want 10 in the output. One can say 5 plus 5, another person can say 5 multiply by 2. So it is different from the network to network that what in between processes we put so that the required output comes. And as the required output comes 1, and this also we decide, no? 1 or 0. We say that for 0, for detecting this 0 shape, I want always be 1. This is user decision. You can say here 0, no matter. But then you have to just decide in the beginning. And for here, if it is X, this is 1. This is what we can decide. Like we decide, no, while designing a circuit, whether it's a logic low level output or logic high level output. This we can decide, no. So if it's a common anode and if it's a common cathode, then logic like 0 glows the LED and 1 also glows the LED. If the cathode is common, 1 glows the LED. If the anode is common, 0 glows the LED. So lights up the LED. So this is what even we decide as a programmer. Me being a programmer, I decide this. And that is how convolutional neural network works. This is one of the example of deep learning methodology. All the methodologies are so very interesting to understand and to learn. In tomorrow's session, Gongre sir also are going to show you implementation and actual programming of many algorithms, which will be a very interesting thing to see. Today I just came down to the end of my presentation. Thank you very much for inviting me for this workshop and for this first session. If some like audiences have some discussion, they can go. Otherwise, thank you very much. I'm finished. Thank you.
Anybody has any queries, they can ask. Okay. So I don't see anybody raising their hand or asking any query. So we'll end the session here. Thank you, madam, for sharing your valuable information on this topic.
Thank you, sir.
Thank you, madam. Thanks a lot. So we will
Thank
meet
you, miss.
again
Thank you.
tomorrow at 3 p.m. The link will be shared in the WhatsApp group, and there will be one more link, feedback link, which will be shared later, just after the session ends today. Okay. Thank you all. We will meet tomorrow.
Sir, what about
Thank you.
record? You will send, sir.
Hello. Pardon.
Hello, sir. This is the Dr. B. Mahabu, sir. What about this record session, sir? Please send this link, sir. Record session.
I'm not able to listen to. Can you put that query in the WhatsApp group so that, or at least raise your voice at least.
Okay, sir. Okay.
I'm not able to listen to you. If you have any queries, you can put it in the WhatsApp also.
Okay, sir. Okay, sir. No problem. No issue. No issue.
Okay, I will share the feedback link for today's session, and I hope everybody fills the feedback. It is mandatory
Okay.
to attend all the sessions. At least 80% attendance is needed. Okay, thank you. Good evening.
Okay, sir. No. Thank you.